Most people do not hate physics because it is hard. They hate it because it starts with formulas before anyone explains what those formulas are even trying to describe. You get handed an equation on day one, full of little letters, and you are asked to solve for something you were never shown. So, of course it feels like a foreign language, but here is the part nobody tells you. Underneath every one of those scary equations is a simple, almost obvious idea about the world. And once you can see those ideas, physics stops being a wall of symbols and starts being the most useful subject you will ever learn. So let's build it from zero. In plain words, no memorizing. Because here is what physics actually is, in one sentence. Physics is the science of predicting how things move, change, interact, and transfer energy. That is the whole subject. Everything else is just detail, and you already do a rough version of it every day. When you catch a falling cup, when you judge if you can cross the street before a car reaches you, when you lean into a turn on a bike, your brain is quietly doing physics. School just tries to write that instinct down with symbols, and somewhere in the symbols, the meaning got lost. We are going to put the meaning back. I'm Daniel, and this is Simplex Academy, where we take ideas that usually feel impossible and make them simple from the ground up. So instead of starting with equations, let's start with 4 questions that physics is really always asking. What is moving? What is pushing or pulling? What is changing? And where is the energy going? Keep those 4 in your head, because almost every physics problem you will ever see is just one of those questions wearing a costume. Let's begin with the first one, motion. Motion just means something is changing position. And to describe it, physicists use a few words that sound fancy but are actually simple. The first is position, which is just where something is. The second is speed, which is how fast its position is changing. A car going 60 miles an hour covers 60 miles of position every hour. Easy. The third word is velocity, and this is the first place people get tripped up. But it is not your fault. Velocity is just speed with a direction attached. 60 miles an hour is a speed. 60 miles an hour heading north is a velocity. That direction matters more than you would think, and you will see why in a second. Because the fourth word is the big one, acceleration. Most people think acceleration means going fast. It does not. Acceleration means changing your motion. Speeding up is acceleration. Slowing down is acceleration. And here is the surprise, even turning is acceleration, because you are changing your direction, which changes your velocity. So when you push the gas, hit the brakes, or take a corner, you are accelerating in each case. A car cruising at a steady speed in a straight line is not accelerating at all, even if it is moving fast. Acceleration is about change, not speed. Once that clicks, half of motion makes sense. You can watch this happen with something as simple as dropping a ball. Let it go, and it does not fall at one steady speed. It starts slow and gets faster and faster the whole way down. That speeding up is acceleration, and gravity is the thing causing it, pulling a little more speed into the ball every instant until it lands. A dropped ball is a tiny, silent physics lesson happening in about 1 second. And now, only now, do formulas earn their place. The equations for motion are simply shortcuts that let you put numbers on these ideas. They are not the physics. They are labels for the physics. When you see a motion formula, it is just a compact way of writing, here is how position, speed, and acceleration relate. You already understand the idea. The formula is just the idea, folded up small. So what actually causes motion to change? That brings us to the second question, pushing and pulling. And the answer is a force. A force is simply a push or a pull. That is the entire definition. And forces are the thing that changes motion. Here is the rule to hold on to. If something speeds up, slows down, turns, or changes direction in any way, a force is behind it. Every time. You can feel this everywhere. When you push a box across the floor, your push is a force. When a ball drops, gravity is a force pulling it toward the earth. When you coast on a bike and slowly roll to a stop, that is friction. A force quietly pushing against your motion. When a car brakes, the brakes create friction that forces the wheels to slow. No motion ever changes on its own. Something always pushes or pulls it. Find the force, and you understand the change. And here is a common myth worth clearing up right now, because it trips almost everyone. People assume heavier things fall faster. They do not. Drop a heavy rock and a light one from the same height, and they land together. The only reason a feather falls slower is that the air pushes against it on the way down. Take the air away, and a feather and a hammer hit the ground at the exact same moment. Gravity pulls on everything at the same rate. That is the kind of surprise physics is full of once you stop memorizing and start looking. This is exactly where a man named Isaac Newton comes in, and he summed up how forces and motion work in 3 simple laws. Do not tense up. We are going to keep these in plain English. The first law says that objects keep doing what they are already doing unless a force changes them. Something still stays still. Something moving keeps moving in the same direction until a force acts on it. This is why you get thrown forward when a car stops suddenly. Your body was moving and it wants to keep moving. The seatbelt is the force that stops you. The seatbelt is Newton's first law, saving your life. The second law is about how much motion changes. It says more force means more change in motion, and more mass makes motion harder to change. Push an empty shopping cart and it leaps forward. Push a fully loaded one with the same effort and it barely budges because it has more mass resisting the change. Same push, different result because of mass. That is the whole idea, and the famous formula for it is just that sentence turned into symbols. The third law is the one that sounds strange but is everywhere. For every push, there is an equal pushback. When you jump, you push down on the ground, and the ground pushes you up. When you step off a boat, you push the boat backward as you step forward. A rocket works the same way. It pushes hot gas down, and the gas pushes the rocket up. Every force comes in a pair, pointing in opposite directions. Once you notice it, you cannot unsee it. Let's take a breath, because that was the core of it. Motion is change in position. Forces are pushes and pulls that change motion, and Newton's 3 laws tell you exactly how. If this is the first time physics has actually started to make sense, that is exactly what this channel is for, so consider subscribing to Simplex Academy. Now let's follow the energy, because that is the 4th question, and it ties everything together. So what is energy? Energy is simply the ability to make something happen. It is what lets things move, heat up, light up, and change, and it comes in 2 main flavors that are worth knowing. The first is kinetic energy, which is the energy of motion. Anything moving has it. A rolling ball, a running person, a gust of wind. The second is potential energy, which is stored energy waiting to be released. A ball held above the ground, a stretched rubber band, a charged battery. All of them are holding energy in reserve. The best way to feel this is a roller coaster. At the very top of that first big hill, the cars are barely moving, but they are packed with potential energy, just from being high up. Then they drop. And as they fall, that stored potential energy converts into kinetic energy, the energy of speed. Top of the hill, mostly stored energy. Bottom of the hill, mostly motion energy. The coaster did not gain energy from nowhere. It just changed one kind into another. And that is the single most important rule about energy. Energy never just disappears. It only changes form. This is where a lot of people get confused, because it looks like energy vanishes all the time. You stop pedaling and the bike stops, so where did the energy go? It did not vanish. It turned into heat in the brakes and the tires and the air. When you charge your phone, electrical energy becomes chemical energy stored in the battery. When you use the phone, that chemical energy becomes light on the screen and a little heat in your hand. The food you eat is chemical energy your body stored from sunlight, passed up through plants, and now turns into every step you take and the warmth of your own body. A light bulb turns electrical energy into light and a bit of heat. Follow any everyday event, and you are really just watching energy change costume. It is always conserved. It never goes missing. That single rule, that energy only ever transforms, is one of the most powerful ideas in all of science, and you now understand it. Before we zoom out, there is one more piece of everyday physics worth pulling in, because you are using it right this second: electricity. It sounds mysterious, but it is really just one more thing moving. Inside the wires around you are tiny particles called electrons, and each one carries a small electric charge. Electricity is simply those charges flowing along. That is the whole idea. When you plug in your phone, the battery or the wall socket acts like a pump, giving those charges a push so they flow around a loop we call a circuit. Picture water being pushed through a pipe. The push is the same idea, just with charge instead of water. And as those moving charges travel, they carry energy with them, ready to do a job at the far end. In a light bulb, that energy becomes light and a little heat. In your phone, it becomes a glowing screen and sound. So notice what just happened. Electricity is not magic. It is another perfect example of our 4 questions. What is moving? The charges. What is pushing them? The battery. What is changing, and where is the energy going? It is being carried through the wire and turned into light, heat, sound, and motion. Same physics, brand new costume. Now let's zoom out, because physics is bigger than motion and energy. And I want you to see the whole map. Physics also explains waves, and 2 of them you use constantly. Sound is a wave that travels through the air. When something vibrates, it pushes on the air around it, and that push ripples outward until it reaches your ear. That is all sound is, a moving pattern of pushes through the air. Light is also wave-like, but a different kind. It does not need air to travel, which is why sunlight can cross empty space to reach us, and sound cannot. Light also travels far faster than sound, and you have seen the proof. In a storm, you see the lightning first and hear the thunder a few seconds later, even though they happen at the same moment. The light reaches you almost instantly, while the sound is still crawling through the air. That gap is physics, live in the sky. And beyond those, the same subject covers electricity, which is moving electric charge, magnets, heat, which is energy flowing from hot things to cold things, and even the tiny world of atoms that everything is built from. Different topics, but all of them are still just answering those same 4 questions. What is moving? What is pushing? What is changing? And where is the energy going? So if physics is really this simple underneath, why does it feel so hard in school? Here is the honest reason. Because it is almost always taught symbols first, meaning second. You are shown the equation for force before anyone tells you a force is just a push. You memorize a formula for energy before you feel what energy actually is. And when you learn the label before the idea, the label becomes something to fear. But you just did it in the right order. You learned what these things mean first. So now, when a formula shows up, it is not an enemy. It is just a shortcut. A small label for an idea you already understand. That is the whole trick. The confusing part was never you. It was the order. So let's bring it home. Physics is not a pile of equations to survive. Physics is a way to see the hidden rules behind everyday life. It is the science of predicting how things move, change, interact, and transfer energy. Motion is just change in position, and acceleration is change in motion. Forces are the pushes and pulls that cause that change, and Newton's laws describe exactly how. Energy is the ability to make things happen, and it never disappears. It only changes form. Waves, light, sound, electricity, and heat are all just more of the same story. And every single formula you will ever meet is nothing more than one of these plain ideas written down short. Once you see it that way, physics is not scary. It is the instruction manual for the world you already live in. So here is my question for you. Comment the physics topic that confused you the most in school, whether it is gravity, energy, electricity, or anything else, and I may explain it from zero in a future video. If this made physics feel simpler, subscribe to Simplex Academy, and I will keep making the hard stuff make sense. I'm Daniel. Thanks for watching, and I will see you in the next one.